Hello everyone and welcome back to Phoenix Gaming. We are going to start a new series today. It's Frosthaven content, so that might not sound new to any of y'all, but we're specifically going to talk about this bad boy right here, the puzzle book that you can open up as part of the campaign in Frosthaven. Now, I decided I wanted to do this series. There is a very excellent resource online by Dwarf SA that you can find on Reddit that gives hints for going through the puzzle book. But I found those hints to be very light touch. So the difference between something that kind of shows you or walks your way through getting to the solution of a puzzle when you can't find it, like I like to have those kinds of validations along the way there. So the idea of this puzzle series is that each of these videos is going to provide a series of hints, followed by me essentially solving out the puzzle, followed by me kind of giving my own personal take or review on the puzzle. A little bit about my credentials on puzzles. I am an okay puzzle guy. I've played a handful of like unlocks and exits. I do sometimes the like special, different like puzzle hunt type of things. One of my friends is really into like the MIT puzzle hunt, which is like way over my head, but I've been a little bit helpful in those. All this is to say that I think that as far as puzzles go, I'm probably smarter than just the average, or not smarter, more experienced than the average cookie when it comes to doing puzzles, but I definitely would not describe myself as a puzzler. So a lot of this is going to come from that perspective of essentially not having that level of experience, which I think if you're watching this video, there's a really good chance that you are in the exact same boat that I am. I think some of these puzzles in this book are more fair than others. You'll see as we kind of go through each of them, kind of what my opinions on each of the puzzles are. But the thing with the puzzles in this book is that they are required for you to complete the campaign. We are actually one scenario away from beating kind of the campaign finale. 75 scenarios completed with side quests and main quests. So we haven't filled all the content in the box, all 139 scenarios or whatever it is, but most of them. And we're about to beat essentially the campaign as it is. Beyond that, everything is just frosting on the cake. And so I thought that creating this video series might provide a lot of help to people. It should be pretty obvious, but I'm going to be extremely clear. These videos are going to be laden with spoilers. The puzzles in this book require you to have unlocked certain content in the game, and so I'm not going to make any apologies. If you're watching this video, you're at a certain stage in the game. If you're choosing to do puzzle book at a certain stage, there's a chance that I'll talk about something that you haven't done in the game yet. I don't think it's going to ruin your experience. I'm not going to go into depth about those things, but just be aware that this like walkthrough guide is going to have spoiler content in it. So that's what you're in for. Without any further ado, I think we're going to go ahead and start talking about puzzle 1. If you're not interested in seeing any spoilers, get out of here. All right, so this is our first puzzle here on page 3. As it says in the text of the book, you don't need any other materials to solve this puzzle. That is absolutely correct. The information on this page is sufficient to solve it. The first kind of hint here is that this is indeed a math puzzle. Plus, minus, times, equals, those all operate in the way that you would expect them to. However, I tried to solve this puzzle algebraically as a math person myself, and it didn't quite work because there are some structures of this puzzle that I would argue are not entirely mathematical in component. So that's kind of my first hint, is that it is a math puzzle, but it doesn't necessarily follow all of the math rules that you would expect for something to be written in this pattern. My second hint for this puzzle is to essentially count the number of unique characters there are. So you've got dots, slashes, dots with slashes, and they're connected in fun different ways. Don't forget that the 3 things at the bottom are, according to the original text, essentially meant to give you a 3-digit number that tells you something to look in the book. So what that implies pretty heavily is that every kind of notation, every indication, every slash and dot collection is a single digit in and of itself, because we've got 3 of those at the bottom of the page. We know we're supposed to end up with a 3-digit number, and that bottom, the very bottom right symbol, the last symbol of our answer that's at the bottom of the page there, does not actually show up in the equation. So it's one of the ones that is unused. I realized it made more sense to have the notes up as I was saying them. So hint number 3 is that adjacency does not mean multiplication. So in that first line right there, dot, 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 did I say enough of them? Does not, suppose that the dot was 6, does not mean 6 times 6 times 6 times 6 times 6, which is what it would be in algebra. Instead, it follows some different rule. What could that rule be? When things are adjacent and they are the same symbol, it does not follow the same rules as when things are adjacent but they are different symbols. You can, I think, maybe from the previous hint, have an inclination of what adjacent same symbols is going to mean, or what your math is going to look like. The adjacent different symbols is going to operate maybe a little bit more like what your expectation would be. At least it was more like what my expectation would be. And it did throw me off when I was doing this puzzle at first, that there are two different rules based on whether the symbols are the same or different. My last hint for you is that the items here follow a rule that is actually different from just solving a math puzzle. In fact, the reason that my partner and I solved this is because she had a wonderful brainstorm about how they looked. So consider how these objects are constructed to help kind of guide you along the way of the digital process. That's pretty much the end for the 5 hints I'm going to give you. At this point, I'm going to move over into solving the puzzle. So if you want to give it a shot yourself, hopefully you've stopped along the way with the hints and tried on your own. If you're completely stuck, follow along with me. We're about to change and walk through it. I will talk through some logic and some stuff that some mistakes that I made as I was going along solving this puzzle myself. All right, let me start off by telling you a little bit about how I sort of got to this answer here. Or at least some of the hints that I got there. So the first thing, one of the kind of key moments was that these numbers don't multiply with each other. And I checked this with these 12 numbers here. I put in, if you put in 1 here, it's 1 times 1 12 times, which is small, but you can't have 2 different digits that are going to then multiply to 1, or 3 different digits that are going to multiply to 1, or however those, adjacent things work. So it was clear that 1 was not the number that went here if it was 1 times 1 times 1. And if it's 2, then 2 times 2 times 2 times 2 times 2 to the 12th power is just too large, essentially, for these things to work out. So I settled on pretty quickly that these numbers are not multiplying each other. Instead, they are probably doing something like adding together, which does, in fact, wind up being our solution here. So this essentially having a ridiculous amount of slashes here is the hint to you that they don't multiply together, but they do have some kind of factor that goes in with each other. So presumably they are then adding together. It is a pretty fair estimate then to kind of come up with just a couple possible values for a slash, right? Slash could equal 1 because we could have like a 3 times 4 situation or something like that. It could equal 2 because 24 has a lot of different things that multiply up to 24. 3 is feasible as well because 36, we could have something like a 9 times 4 situation, or 6 times 6 if this could be like 3 and 3 and this is 6 or something like that. We could have it as 4, 48, because we have like 6 times 8 gets up to 48. But then we start to get into dodgy territory, because if we have 5 or anything higher than that, 5 12 times is 60. And really, we don't have anything that can multiply to make 60 out of single digit numbers. It is possible if these things add together, if this is like 6 and 6, and then this is 5, but this was already 5, so that doesn't feel too good. So we could be looking for like, right, because the factors of 60 are 6 times 10, 5 times 12, 3 times 20. So those numbers are too big, and we could get maybe like a 4 times 15 situation, but it's really unlikely that 2 values are in any way going to get to 15, be they digits or adding together or whatever it is. So 5 gets really sus to the point that I would say it's not even 5, and then at 6 and higher, we could have a 6 here because that's a 72. And we could have something like a 9 times 8 situation. So these are the highest, but again, getting pretty dodgy here, and it certainly can't be anything 7 or above. So we have some limitations here, but my instinct, even just like going through this, is that a slash is going to be on the lower number side. Otherwise, it sort of restricts these two to be some pretty high numbers, regardless of whatever this like double value does. Then jumping back up here, I want to think about the same thing with my dots. So with my dots, I've got dots could be 1, right? This whole thing could add to 5, something minus something plus something could be 5. That's pretty easy. Could certainly be 2, right? If this is 10, again, you could have some digits that add to 10, or it could maybe be 3, which becomes the kind of cap of what we have here, because the biggest numbers we could have, like let's say we had like 9 plus 8 minus 2 here, that's 17 minus 2 to get 15. That's the highest we could possibly, or like 9 plus 8 minus 1 for 16 would be the highest we could get. So there's absolutely no way that the dot is anything 4 or higher. We know that the dot's got to be a 1, 2, or a 3 according to these rules so far. And the 3 is very limiting. If it's 3, then big numbers go here and a teensy little number goes here. It's also worth noting that this right here, the slash, is the same as these slashes here. And we think that that's probably on the lower or at least middling side. But we did not think, right, there's no 9 plus 6. So actually, since we know that the slash is not a 7, 8, or 9, we also know that the dot is not going to be a 3. So we've kind of narrowed down the dot a pretty significant amount to a 1 or 2, which really means that these items could be a whole lot of different things. 3 digits that are going to add to 5, right, 1, 1, 1, 1, or 10, 2, 2, 2, 2, 2, is a bit too much there. We fiddled around a fair amount, and you can go barking up this tree too, but I already kind of gave you this hint that, this number times this number plus this number times this number equaling this number times this number just didn't really end up working out. And this kind of has even the look of something that is like digits, right? Like this is something like 34 plus 56 equals something, like that feels to me more like what this is. So I'm going to go with that intuition here, which again winds up being correct in this instance. The one thing that I find really helpful here is that we see, first of all, our friend the slash shows up again. Our friend the slash dot shows up again. This guy shows up again. And then these show up. And this is really significant in that this is in the single digit, the units digit, and this is in the tens digit. Usually when you see that, you're looking at something like, like this is a high number, like 18 plus 64 becomes 82 or something like that, right? Like oftentimes this being the same register as this means that there's kind of like a rollover value in number. It can, I guess, mathematically be that this was a really high single digits number, and then essentially these numbers add up to make this essentially the value. Like I guess if you had something like let's come up with an example, like let's say 12 plus, well, again, this is a terrible example, like 32 plus that doesn't work. So the problem that you're seeing me come across here, and even coming up with an example of like why this couldn't be a low number, is because if this is a low number, these also must be low numbers because they can't add to that high of a value here. So this has got to be something like maybe like a 5 or 6 in that example. Let's say it's like a 6. So this could be like a 16 plus whatever, 40 something, 48 equals 64. That specific example doesn't work because we've reused 4 in 2 instances for 2 different numbers. And you often come across difficulty like that. So it is plausible that this is a high digit and these are low digits, or in this case actually more likely middle digits. You can't really have them be low digits, but I think it's a fair assumption to say that these digits are going to be on the higher side of digits. We're not really looking at a 1 or 2 or 3 as these numbers right here. So that's, I think, a helpful perspective to take as we've kind of laid out some rules here. I failed a bunch with algebra with some things here, and there's a problem in the way that this problem is structured that actually made me come to a complete dead end when I was trying to solve this algebraically. Maybe someone who's much smarter than me can get there. But then, because I was talking to my partner about the parameters that I'd figured out, which is that this is a low number, this is probably a low number, and then I was trying to figure out what the rest were. And the problem that I was coming across is that I have 1, 2, 3, 4, 5, 6, 7, 8, and then the answer. I have 9 digits here, so probably not a 0. along the way. But the problem with having the 9 digits here was that everything I was solving, this number wanted to be another number. And I got really stuck on that. You'll see what actually ends up happening with this, and I'll talk about that a little bit later. But every solution that I had kind of some miss along the way. You can brute force this from here. You can kind of just plug in different numbers until essentially you get somewhere that works using these numbers. However, my partner had a flash of insight and said, well, okay, these you think are lower numbers based on the different kinds of like numbers that you've put in and played through. Well, like what if they actually are literally 1 and 2? Because look at how simple these numbers are, or the icons for these numbers are, right? This is just a dot, this is just a slash, and so perhaps like they are literally the numbers 1 and 2, or 0 and 1. So first of all, we tried doing things with 0, which was very quickly eliminated. 0 does not really work in this puzzle. It's clear that that is not really a feasible digit to be represented, which is fine. The Arabic numeral system, I don't think, invented the number 0 until like 1,000 years ago or something like that. So that's totally reasonable. And we settled on them being 1 and 2. I worked around a couple ways of making these numbers a 1 and getting sort of like a 3 times 4 situation, which became, I mean, in order to have a 3 times 4 situation, it seemed like this number was 2 and this number was 3, right? 2 and 2 for 4 times 3 to make 12. Well, that didn't really work. So what if this just was 3 or just was 4 somehow? Then that meant that was 2, and I tried all that out and it didn't work. So that left us with, this is probably not 1, essentially, by doing that process of elimination. And then we'll go through from here and I'll show you essentially the solution if you have worked your way through that mess, if you buy what I've said so far, and land on, let's try this as 1, which makes this a 5. So we've got a dot equals 1. We've got the slash equals 2. So this right here is 24. We've got 2 here. And we know that these numbers together need to add essentially to make 3. So the difference between these two numbers can only be 3 apart from each other, which means we've already used 1 and 2. So we could have, for instance, 6 minus 3, 7 minus 4, 8 minus 5, or 9 minus 6 here. That would be all very reasonable. Here we've got 24, which means that we have a situation where we're either doing a 4 times 6 or an 8 times 3. I really think that this is an even number because it's got a double thing going on here. So I don't think this is a 3. So this could be a 3, right? We could have an 8 times 3 situation, or we could have like a 6 times 4 situation, or a 4 times 6 situation. Those are kind of the, I think, reasonable assumptions to make under these rules here. So assuming that we know this, down here we've got plus 20 something, right? 23, 24, 25, 26, right? 3, 4, 5, 6. So 23 through 6, okay? And here we've got either a 30, 40, or 60, 30, 40, or 60 something. That's probably a higher digit because we've not really used a lot of higher digits so far. So something there that we think is a higher digit. And we think it's a higher digit because it adds, up to, like I said, this is probably a higher digit here. And then this is, again, a 3, a 4, or a 6 right there. Now I'll pause here just to say that you might have actually recognized the pattern that exists in the creation of these things that tells you already what the answer to this puzzle is. I'm going to pretend you haven't noticed the pattern, and we're going to just talk about it a little bit mathematically, and then we're going to go back to talking about the pattern again based off of this sort of like low number structure that we have established for these numbers here. So let's pretend that the question mark is the biggest number it could be. It's a 9. So then if this is a 9, that means that this number would have to be a 6. And I'm also realizing that this number does not need to be a 3, 4, 6. So it's just essentially the leftover number because this is not that. It's just this. So sorry, if this number is a 9 here, we've got 9 plus 20 something equals something 3, 4, 6, right? But if this is a 9 and this is a 3, then it would add to a 2 single digit. So that doesn't work. If it was a 4, it could add to a 3 single digit. So that works. Could be a 5. 5 goes to the 4 single digit. But it couldn't be a 6, right? So this is kind of implying, all right, well, if this is a 9, this is a 4 or 5, that means this is a 3 or a 4. So if this is a 3 or 4, we can kind of like figure out what that stuff is. And you can essentially work through back solve that way. You could try like with an 8 and then essentially again get to this point and plug in numbers from there. However, the more clever thing is to make the notice. The notice is that we said these were the two simple icons. That's one dot, that's two dots. And so here, that is a dot and a slash, which seems like the next simplest icon of all the icons on here. And in fact, if this is 2 and this is 1, wouldn't it be reasonable to think that this is 3? So let's try thinking that this is 3, which would make this 8, which seems pretty logical because we've got a 4 and a 4 going on here. So I would buy that that works as an 8 there. And then if we're kind of following this pattern, well, maybe this is a 1, 2, 3, 4, 5, 6. This is a 1, 2, 3, 4, 5, and we'll call this 2 lines for 6, 7, 8, 9. So all of a sudden we've got 9 here, 6 here. So let's see we're landing on 3 here, and then 8 there. So we've got, this is, oops, other way. This is 3. This is 9. This I think is 4 because we've got this being 8. Come back to that. This is 6. So if this is 6, we've got a 26 going on down here. And this we think is a 3. So something plus 6 is 3. So that means that's got to be a 7. So that's got to be a 7, which would make this number a 4. So that would tell us that we've got this 7 looking thing as a 7, which just feels like maybe kind of a intentional hint, I think, along the way there. And we've got this as also representing a 4, like maybe like this does. And we have one missing number, which is the 5, which is this guy right here, which was 1, 2, 3, 4, 5. And so you see that you could actually solve this problem through essentially mathematical means, but it would be a lot of guessing and checking. And instead, looking at the structure of the language is where we landed on our answer. If you found a more clever algebraic way, please drop it in the comments so that people who are trying to solve this puzzle in that pattern are going to be able to figure out what's going on there. So that's how we solved this puzzle. And kind of the logic behind it. We sort of stumbled on it backwards. It was a lot of guessing and checking along the way, and probably because I was very stuck on an algebraic solution, whereas my partner, after kind of seeing me working on it for a while, kind of came in and like swooped in with the solution after kind of looking at it a little bit based on essentially what I'd said, right, that I think these numbers are slow was my only contributing factor to the solution that we landed on there, and then the checking to make sure that the numbers are correct afterwards. So let's talk about my opinion about this puzzle. This took a lot longer than I thought it would for what it was, and that's probably because of the way that I chose to approach it. I think that there are a couple things about this puzzle that I didn't love, but on further reflection, I was willing to forgive. So for instance, I didn't really love that this and this symbol both seem to make 4, that like one is kind of slanty and the other one is not. To me, well, so first of all, I think it's actually also unclear. This here might actually just mean 8, but I think that if it does mean 8, it should have to be connected. Like, I think what I would imagine 8 would look like would be something like this, right? That would be an 8 to me if I was following the rules of this universe. That being said, when I reflected on it, you know, language is really messy, and the way that people land on certain numbers and letters and the way that notations are is very natural, right? It's very organic. And so I don't like this like straight up and sideways structure, meaning similar numbers, for this puzzle as a structure, but as a language, I'm willing to buy it a little bit more. Part of the reason this annoys me is because we don't have the slash here sideways and these slashes here being collapsed over like this as like one standing and one not. Like, to me, I think the 24 here, if this is like how we rule 8s, should be like 12 straight up and down slashes. That's just essentially my take on how I think this like language structure would be a little bit more intuitive, at least for my brain. So that was a thing that was like a little annoying to me. I also didn't super love that the digits here, the digits of the different things, operated differently than the ones that were adjacent to each other. Again, I was willing to forgive that. I landed on that, but I spent a lot of time trying to treat them as if they were following the same rules when they really just weren't. And there's not really any indication one way or another that would be the case. So definitely a bit of a dead end there. But overall, I thought that this was a neat little puzzle. It was certainly difficult to the point that I thought there might have been some hints somewhere else. And so even from puzzle one, I was like, okay, this is going to be a pretty rough puzzle book. And I did not know what I was in for. So that's the first of the videos. The other ones will probably be, well, it depends on the puzzle. Maybe be a little bit shorter, depending on essentially what we're getting into, but also because we don't have the introduction there. So hope you enjoyed the video, and we'll keep producing these until I've got essentially the full series. That's the plan. All right, thanks everyone. Have a great day.